Hello my students, welcome to my channel. Today we have to start a new journey of differential equation, right? So you have to start your first chapter, basic concepts of differential equations, right? So the mathematical formulation of many problems in science, engineering, economics give rise to differential equations. For example, the problems of motion of a satellite, the flow of fluids, the flow of current in an electric circuit, the growth of population, the increase in pollution, the change in prices of commodities, the conduction of heat in a road, etc., leads to differential equations. Each of the other problem is characterized by some laws which involves a rate of change of a quantities with respect to another quantities. As we know that when we have to involve the rate of change of quantities, that it involves the derivatives. Okay. Uh, so the laws characterizing these problems which involves their derivatives, when you have to express in mathematically, it is called differential equations, right? So simple, that is very simple. That means we have to involve the rate of change of quantities, and when it is called about rate of change of quantities, that it involves derivatives, and when it is expressed mathematically, it is called differential equation, right? Now basically we have go to the definition of differential equations, then we have to go to the classification of differential equation. So first of all, let's discuss the definition of differential equation. Let's talk about the definition of differential equation. Look at the definition. A differential equation is an equation involving derivatives of one or more dependent variables with respect to one or more independent variable. The first, let's know which one is dependent variable and which one is independent variable. Okay, look at here, dy by dx. In that case, y is the dependent variables and x is the independent variable. That is very easy. Y is the dependent variable and x is the independent variable. So look at the definition of differential equation. A differential equation is an equation involving derivatives of one or more dependent variables with respect to one or more independent variable. Here y is the dependent variable and x is the independent variable. So look at the examples. So first example is dy by dx plus xy is equal to x square, dqy by dx cube plus x4, d square y by dx square, and dy by dx, which are 4 plus y equal to sin x. And the third example is del u by del t plus del u by del x whole square is equal to 4. And the fourth example is del square u by del x square, del square u by del y square, and del square u by del square del z square equal to 0. So these are the examples of differential equations. So basically, you know that is what is differential equation. If you have to say in a simple language, that means the equations involving derivatives. It may be ordinary derivative, it may be partial derivatives, is called a differential equation. Simple. What is differential equation? The differential equation is what? Now the equations involving derivatives is called a differential equation. That is the definition I have to write here. That means the differential equation is an equation involving derivatives of one or more dependent variables with respect to one or more independent variables. That means y is the dependent variable and x is the independent variable, right? So now let us discuss about the classification of differential equation. Now let's talk about the classification of differential equations. As we know that derivatives is of two types. One is ordinary derivatives and another is partial derivatives. Similarly, the differential equation is classified into like that, ordinary differential equation and partial differential equation. So let's talk about ordinary differential equation, right? So a differential equation involving total derivatives is called a ordinary differential equation, and similarly a differential equation involving partial derivatives is called partial differential equations. Look at the first two examples. dy by dx plus xy is equal to x square dqy by dx cube plus x4 d square y by dx square plus dy by dx whole to the power 4 plus y is equal to sin x. These two are basically ordinary differential equations, and the rest three are partial differential equations. You have to clearly see this one. It is very clear. Okay. If you have to talk about dependent and independent variables, so in case of ordinary differential equation, there is only one independent variable, but in case of partial differential equation, you have to see that more than one independent variables are present. In the first differential, in the first two examples, there are only independent variables, that is x. But in case of 3, 4, and 5, there is more than one independent variables. That in the case of third one, there will be two independent variables, t and x. In the fourth, oh sorry, the two are same. The fourth and the fifth are the independent variables are x, y, and z. Okay, so if you have to simply say that, if you have to define the definition in terms of independent variables, if it is involved one independent variables, then it is called ordinary differential equation. If there are more than one independent variables, then it is a partial differential equations. I hope you have to clear about the ordinary differential equation and partial differential equations. So let's talk about more classification of differential equations on the basis of order and degree. Okay, so let's see. Now we classify the differential equations on the basis of order and degree. So first of all, understand what is order and what is degree of the differential equation. A differential equation is said to be order n if the order of the highest order derivative is n. And what is degree? Now, a differential equation is said to be degree n if the degree of the highest order derivative is n. So let's take some examples. So here the first example, that is dy by dx plus xy is equal to x square. So look at the number of derivatives. So highest number of derivative is this one, dy by dx, and here there will be one times derivative will be occurred. So order is 1, and the power of this highest order derivative is 1. So degree is 1. Look at the second question. In the second question, there will be a third order derivative. So this one, and its power is 1. So order is 3 and degree is 1. Look at the second question. The third question, there will be the highest order derivative is 1 and degree is power is 2. Look at here. And look at the fourth one. Here highest number of derivative is 2, so that is order is 2 and its power is 1. So degree is 1. Here we have to see the simple cases. Now we have to see some more examples to understand the concept of order and degree of the differential equation. Let's see. Always a question arises that we can find the degree and order of every differential equation. The answer is simple. Order of any differential equation can be defined, but the degree of the differential equation of any type of differential equation cannot be defined. Then the next question is where we cannot find the degree of the differential equation. Look at here. I have write down here when the degree of the differential equation is not defined. So if a differential equation cannot be expressed in terms of the polynomial equation where the highest order derivative has the leading role and the degree of the differential equation is not defined, here that means simple. If you cannot express the highest order derivative in polynomial equation, then you cannot find out the degree of the differential equation. Okay. The second one, the degree is defined only if the polynomial function of derivative can be generated. Okay. And the third one, if the differential equation has log, exponential, and trigonometric function of the derivative, it is not possible to define its degree. Simple. You have to find out. If you have to find out the degree of the differential equation. That means Derivative y dash y double dash should be right in the polynomial equations that does not contain uh, log, exponential and trigonometric functions. Okay, so let's see some examples. So here dy by dx plus sine of dy by dx. Look at here the third one, third point of the given, that is it should not be contain trigonometric function. Here the derivative dy by dx sine of dy by dx. So that's why this is not in the polynomial form of y dash the y double dash and like that. So this here the order is one, okay, but the degree is not defined. Is not defined. Look at the third one, second one, y y third dash y triple dash plus y square e to the power y dash equal to 0. So here also this one, so order is 1, order is 3, but degree is not defined. Okay, look at the fourth one, d4y by dx4 plus sine y triple prime so equal to 0. So here the order is 4, but degree is not defined. Okay, in the fourth one also d square y by dx square plus cos of dy by dx equal to 0. Here order is 2, but degree is not defined. Not defined. Okay, here also d square y by dx square plus 3 dy by dx equal to x square log d square dx square. Here also order is 2, but degree is not defined. Okay, and the next one sine. Okay, look at here very carefully. X is equal to sine of dy by dx minus 2y is equal to mod x less than 1. But in that case, if you have to write this one, sine inverse x plus 2y is equal to dy by dx. Look at very carefully. There is no terms of log, exponential and trigonometric function in the primes of y and derivatives. Okay, so that's why here the degree is defined. Okay, so here the order is 1 and degree is 1. Look at the seventh one, x minus 2y log of dy by dx. This also we can write e to the power x minus 2y dy by dx. So here the order is 1 and degree is 1. In that case, the order and degree of the differential equation is defined. Okay, look at here, 1 plus d square by dx square whole to the power 3 by 2 equal to k whole into d square y by dx square. So it should any differential equation should be uh, out of fractions. So that's why we have to squaring on the both sides. Squaring on the both sides, it should be like that, k square d square y by dx square. So okay, so then it should be becomes, actually this is a dy by dx, sorry, this is dy by dx square. So that is so that's why the order is 2 and degree is also 2. So order is 2 and degree also 2. So this is all about order and degree of the differential equations. Let's classify the differential equation on the basis of linear and non-linear. Okay, so let's check it. Let's classify the differential equation on the basis of linear and non-linear. Okay, so first of all, we have to understand the definition of linear differential equation and the second one, non-linear differential equation. Okay, so let's see the definition of linear differential equation. A differential equation is said to be linear if the dependent variable and its differential coefficient occurring in the equation of first degree only and not multiplied together. Okay, then it is called a linear differential equation. It is non-linear. A differential equation is called non-linear if it fails to be linear. Okay, we have to make simplify the first definition for linear non-linear. Okay, if you have to understand the condition of non-linear, then it is quite easy to check the linear differential equation. Okay, so when you have to see any differential equation and the question is to check the linear and non-linear, first of all always important the non-linear. Okay, so I have make a 4 steps to understand the non-linear. Okay, So okay, look at the here. A differential equation will be non-linear if its degree is more than 1. If degree is more than 1, then it is a non-linear differential equation. Any of the derivative has exponent more than 1. And the third one is exponent of the dependent variable. Here dy by dx, and y is the dependent variable, x is the independent variable. So this one, exponent of the dependent variable is more than 1. Products containing dependent variable and its derivative are present. Products containing dependent, that y, and if dy by dx is present, that is not a linear differential equation, it is a non-linear differential equation. So look at the first example here. We have to take some examples. dqy by dx cube whole square minus 6 d square y by dx square minus 4y equal to 0. Look at here. Here the degree is 2. Here the degree is 2. Okay. So that's why this is a non-linear differential equation. That should be fails the first condition. Look at here. Its degree is more than 1. So if its degree is more than 1, then it is a non-linear differential equation. So that's why the first one, that degree is 2. So that's why is a non-linear differential equation. Look at the second example. D square y by dx square plus 2 into dy by dx plus 9y is equal to x. There is no problem that degree is more than 1. So degree is 1, but look at here, dy by dx. Here any derivative, look at the second condition, any of the derivative has exponent more than 1. If any derivative dy by dx is present and its exponent is more than 1, so that's why this is not a linear differential equation, this is non-linear, right? Look at the third example, dy by dx plus y square is equal to x. So here y square. So look at the first, second condition, we are satisfied. And look at the third condition, exponent of the dependent variable is more than 1. Y is the exponent if dy by dx and y is the dependent variable. So then here we have to see that y is the dependent variable and its exponent of the y is true. So that's why is non-linear. And the fourth one, products containing dependent variables and its derivative are present. So look at the fourth example, d square by dx plus y dy by dx plus x equal to 0. So that's why this is a nonlinear differential equation because of the fourth condition. Products containing dependent variables and its derivative should present here. So that's why this is a nonlinear differential equation, y into dy by dx. So that's why this one is nonlinear. Okay, so always you have to check the nonlinear condition, then after that you have to check the linear conditions. Okay, I have to give another example, dy by dx plus xy is equal to 4. So here this is simple linear differential equation because look at here, it's said to be linear if the dependent variable, that is y, and its differential coefficient is equation of the first degree only. Look at here the derivatives and y is has exponent 1 and is not multiplied together, so there is nothing to worry that they have to multiply together a derivative and the dependent variable. So that's why this is a linear differential equation. Okay, so this is a linear differential equation, so it is very clear. I think you have to understand the linear and non-linear differential equation. Okay, now we have to see some more example. I think you have to think like that these are the exercise questions. So let's solve the problems. Let's solve an exercise questions. Look at here. First of all, pause this video and try to solve yourself. After that, see my answers. Okay. Look at here. Classify the following as ordinary, partial differential equation, linear or non-linear differential equations. In each case, you have to find out the order and degree of the differential equation. Okay. First of all, y dash plus xy equal to e to the power x. Okay, the ordinary. This is ordinary. This is ordinary. Okay, this is linear or non-linear. Look at here, this is a linear differential equation, no doubt, and order is 1 and degree is also 1. Order is 1 and degree also 1. Look at here, y double dash y dash square is equal to sine x. Okay, it is ordinary, no doubt, but it is non-linear because the power of and derivative is there whose exponent is 2. Y dash has exponent 2, so that's why this is non-linear. Okay, and order is 2 degree is 1. So order is, there is a second order derivative and its power is 1. Y double dash plus y dash equal to x. So it is ordinary, no doubt. Okay, it is linear or non-linear. Here there is y into y dash. Okay, product of a dependent variable with its derivative. So that's why this is non-linear. Non-linear. Okay, and order is 2, degree is 1. Look at here, x square y third minus square root of x into y. Okay, it is ordinary, no doubt. It is linear or non-linear? Okay, it is linear. And order is 3, degree is 1. X square dy plus y square dx, no doubt it is ordinary. But it is non-linear because y square into dx. Y has exponent, y has the dependent variable and its exponent is 2. So that's why this is non-linear. And order is 1, degree is 1, no doubt. Next, this one, it's ordinary, no doubt. It is non-linear because of that one, y dash has exponent 3, so it is non-linear. Okay, order is 4, degree is what? Degree is 1. Okay, look at it, dy by dt plus dy by dt whole square plus 1. So first of all, solve this one, dy by dt. Take squaring on both sides, it is 6 is equal to dy by dt whole square plus 1. So it is ordinary, no doubt. It is non-linear because that its power is, order is, its degree is 6. Order is 1, degree is 6. So that's why this one is non-linear. Look at here, x del u by del x plus y del u by del y equal to x square y. Okay, no doubt this is partial. Okay, and product, okay, there is no product, so it is linear. Okay, linear, and order is 1, degree is also 1. Order is 1, degree also 1. No doubt it is partial. It is non-linear because of this, because product of dependent variable and its derivative is there, so this is non-linear. And order is 2, degree, its power is 1. So order is 2, degree is 1. So this is also partial. Okay, it is linear or non-linear? Del square, it is linear, no doubt. It is linear. Its order is 2 and degree is 1. I hope you have to understand all the problems that are given here. Now let's know what is the solution of a differential equation. We have to learn the solution of a differential equation. So let's see. Dear students, let's understand the solution of a differential equation. Okay, so first of all, we have to see what is solution of differential equation. Look at here. The solution of a differential equation is a relation between the variables involved which satisfy the differential equation. In layman language, you have to simply say that solution means it should be satisfy the differential equation, right? So there are different kinds of solutions of a differential equations. Basically, there are three types: general solution, particular solution, and singular solution. So let's know about what is general solution. So basically, a solution of a differential equation is called a general solution if it contains many arbitrary constants as the order of the differential equations. So simply, general solution means it contains some arbitrary constants as the order of differential equation. If there are order is 2, then there is 2 arbitrary constants. Okay, for example, here I have to give an example. Y equal to c e to the power x is the solution of the differential equation dy by dx equal to y. So here the order is 1, so that's why there is a constant c, there is a single constant c. Okay, so this one is the solution and it should be satisfy the given differential equation. Then we have to know about the particular solution. So what is particular solution? A solution of a differential equation is called particular solution if it can be obtained from its general solution. That should be obtained from its general solution by assigning particular values to its arbitrary constant. That means The particular solution actually obtained from the general solution by assigning suitable values to its arbitrary constants. Example, so y equal to 2 e to the power x is the particular solution of the differential equation dy by dx equal to y when x equal to 0, y equal to 2. So that means from this equation we have to obtain the this particular solution. If you have to put in place of x 0 and y equal to 2, then you get c is equal to 2, and then you have to assign in here the value of c is equal to 2 and y equal to 2 e to the power x. This is the particular solution, this is the general solution, and this is the particular solution of the given differential equation. Okay, this is the simple difference between general solution and particular solution. So let's know about what is singular solution. Singular solution is basically different from particular solution and general solution, that should not be obtained from its general solution. That means, like particular solution, singular solution is not obtained from its general solution. Okay, look at here. A solution of a differential equation is called singular solution if it cannot be obtained from its general solution by assigning values to its arbitrary constant. That is, this is a different solution. This is a particular kind of solutions. So y equal to x square by 4 is a particular solution of the differential equation. Okay, and dy by dx minus x dy by dx plus y equal to 0. And this is a singular solution. This is the singular solution of the given differential equation. Okay, this is all about the definitions. Let's try some problems. Okay, dear students, look at the problems. Verify that the function y equal to e to the power minus 3x is a solution of the differential equation d square y by dx square plus dy by dx minus 6y equal to 0. So let's see the solution of the question number 1. Look at it. So y equal to e to the power minus 3x. So derivative you get y dash. This is minus 3 e to the power minus 3x, and y double dash is 9 e to the power minus 3x. Now uh, putting the values of y dash, y double dash in the given differential equation. Okay, so what do you get? This is LHS d square y by dx square plus dy by dx minus 6y. So this is 9 e to the power minus 3x plus, sorry, this is minus 3 e to the power minus 3x, and this is minus 6 e to the power minus 3x. So this is 9 e to the power minus 3x minus 9 e to the power minus 3x, which is equal to 0. So this one, y e to the power minus 3x, is a solution of the given differential equation, this one. Okay, so you got that. And go to the next question. Verify that the function y equal to a cos x b sin x. So remember that one, a b belongs to R, is a solution of the differential equation d square y by dx square plus y equal to 0. So you can solve similarly a cos x plus b sin x. So y dash is minus a sin x plus b cos x. Y double dash is minus a cos x minus b sin x. So putting the values of y and y double dash in the given differential equation we get, what do you get? You got d square y by dx square, this is LHS, plus y, and what do you get? Minus a cos x minus b sin x plus a cos x plus b sin x. So you got 0. So this is the RHS, and this is the RHS actually. So LHS equal to RHS. That means, so this one is the solution of the given differential equation. Okay. I hope you have to understand this concept of solution of a differential equations. Let's know about the formation of a differential equation. So let's see. Talk about the formation of differential equations. To form a differential equation is quite easier than to solve a differential equation. Formation of differential equation, you have to just eliminate the constant, you get the differential equation. Look at the first question here, y equal to ax plus a square. You just have to eliminate the constant. Y is ax plus a square and y dash is a. So now Y is, you have to put the value of a here, x y dash plus y dash square. Simply you get eliminate the constant, you get the differential equation, and this is the differential equation. Okay, now look at the second question here. Y equal to a cos x plus b sin x. So just derivative on both sides. Y dash is a sin x plus b cos x, and y double dash is what, minus a cos x minus b sin x. So this is y double dash. I take a minus common, y cos x plus a cos x plus b sin x. And this is y. So minus y. So that is y double dash plus y equal to 0. So this is the differential equation that you have to get. Now the third question is y square equal to ax square plus bx plus c. Okay. So taking differentiate on both sides. So this is 2y y dash. This is 2ax plus b. Okay. Now take a differentiate again. So what do you get? This is 2 and this is y dash square. Okay, and this is 2y y double dash. Okay, you get 2a, right? Now again differentiating, that is look at here. This is 4y dash. This is 4y dash, again y double dash plus 2 y dash y double dash plus 2 y third, and it is 0. I think you got it. I think this one is 2 y dash y double dash. Okay, you have to take constant. You have to just put you have to just use the formula uv, and this is 2. Okay, taking 2 common on both sides, we get 2 y dash y double dash. Okay, y dash y double dash, this is 4 actually. 4 plus y double dash equal to 0. I think so. This is 3 y dash y double dash. You got that. That is actually, this one is 6 y dash y double dash plus 2 y triple dash equal to 0. So that's why you have to take common. So this is 3 y dash y double dash y double dash equal to 0. So this is the required differential equation that you have to got. Okay, so now let's discuss about the initial value problem and boundary value problem. We have to see that what is the difference between the initial value problem and boundary value problem. So let's see about the initial value problem and boundary value problem. So first of all, know what is initial value problem. So basically, if the conditions involves prescribed at one point of x, the problem is called initial value problem. Look at the example here. You have to take an equation d square y by dx square equal to cos x with the condition y of 0 equal to 1 and y dash 0 equal to 2. Look at here. Here x has single value. Look at here. Clearly the two conditions are prescribed at one values of x equal to 0 and x equal to 0. Look at here. Here x equal to 0 and x equal to 0. So that's why, so the given problem is an initial value problem. Okay, if there is single conditions. Look at the second one. On the other hand, if the conditions involve prescribed values at a two different values of x, the problem is called boundary value problem. Look at here. Consider the differential equation d square by dx square equal to y plus y equal to 0 subject to the condition y of 0 equal to 0 and y of pi by 2 equal to 1. And that means x has two different values, x equal to 0 and x equal to pi by 2. So in that case, you have to say that this is a problem of boundary value problem. So the simple difference, if x has single value, then it is a initial value problem. If x has two different values, then this one is a boundary value problem. Okay, I hope you all have to clear all these things that I have to talk. Okay, again, an important thing. Remember one thing: initial value problem is not a unique. I mean, initial problem has no unique solutions. Remember that. See, there are some conditions that the problem will be unique, but the problem is the initial value problem has no unique solutions. It has some conditions that the initial value problem has a unique solution. So that's to be discussed later. Actually, we have to discuss all of these things laterally. So this is all about in the whole class. We have to learn about the basic concept of differential equations. I think this is over. In the next video, we have to talk about how to solve differential equations. This is all about. We have to discuss about order, degree, that means definition of differential equation, classification of differential equation. Later, we have to discuss about the solution of differential equation, then formation of differential equation, and lastly, we have to discuss about the initial and boundary value problem. This is quite easier. This is about the basic concept of differential equations. The next video, we have to see solution of differential equations. Okay. So thank you to all of you. See you in next class.